A 5 kg glass block which have an initial temperature equals to 30 degrees Celsius is in contact with the asphalt whose initial temperature is equals to 75 degrees Celsius, whereas its mass is 20 kg, 4 times more massive than glass. And one more important thing is to note that the specific heat capacity of the asphalt is 2 times of specific heat capacity of this glass, which simply means, conceptually means, that asphalt needs 2 times more energy to rise its temperature by 1 Kelvin or by 1 degree Celsius. So first of all, its specific heat capacity is more than glass specific heat capacity, and second, its mass is more than the glass. So that's why you will see a very small change in temperature in the asphalt, which means that the temperature of asphalt will decrease, but that decrease in temperature will be not abrupt like this. On the other hand, the glass temperature will increase more because its specific heat capacity is small. That's why we can expect this is the temperature of the glass. So at some time, both temperature will become equal. This is our equilibrium temperature, and that's what you have to calculate in this question. And you see that the heat lost by the hot body, and it is mentioned in the question, no energy is lost, which means all the heat that will travel from the asphalt to the glass will not be lost. So we can say that the Q gain, the energy that is gained by the glass plus the energy that is lost by the asphalt, the sum of these two energies is equal to zero, because same energy is gained and lost. So which can be written as minus Q lost. So which object is gaining energy? That is the glass. So we will write the mass of glass, specific heat capacity of glass, and the change in temperature of glass. In the same way, we will write for the asphalt. So mass of glass is 5 kg, specific heat capacity of glass, and the change of temperature of the glass is final temperature, that is equilibrium temperature, minus 30 degrees Celsius is equals to negative. And specific heat capacity of asphalt is 2 times, so we can say here 2 Cg into the change of temperature of asphalt is final equilibrium temperature minus 75 degrees Celsius. You can take this negative inside the bracket, so it can be written as 20 times 2 is 40 Cg into 75 minus T. So we can cancel this specific heat capacity of glass with this one, and 5, and this is 8. So we have got a simple equation, and that is T minus 30 is equals to 8 times 75 minus T. So that will be 8 times 75 is 600, whereas this is negative 8T. These are the easy algebraic steps. So 630 over 9 is the final temperature in the Kelvin, or sorry, in the degree Celsius. That will be equals to 70 degrees Celsius. And you have seen that, as I said, that the temperature of the asphalt will change, but very slow, at a very slow rate, because its specific heat capacity is twice. Its mass is 4 times more than the glass, and we have finally got that equilibrium temperature, that is 70 degrees Celsius. So option D is the right answer for this equilibrium temperature, final temperature.